Hello there, Mr. Sutton here, bringing you the Algebra 2 5-4 Part 2 homework solutions on solving equations with radicals and rational exponents. For this problem, we've already got the radical expression isolated, so we can go straight to using an exponent on both sides. Since this is a square root, we're going to square both sides. So I'll have just plain old 3x on the right side, and I'll have x minus 6 quantity squared on the left side. Let me expand out that left side so I can move things together at some point. So we're going to have x squared and then multiply these together and double it for the middle term. So that's going to be negative 12x. And then finally plus 36 equals 3x. And then just one little extra step. Let's subtract this 3x over to the left side to get 0 on one side. So negative 12x minus 3x is going to give us negative 15x over there. Now we have a quadratic, and it's 1x squared, a equals 1 there. So I think I should at least try factoring this first. Are there things that multiply to 36 and add up to negative 15? Well, let me think. 1 and 36, no. 2 and 18 doesn't work. 3 and 12. Well, negative 3 and negative 12 adds up to negative 15. So we have x minus 3 and x minus 12 equals 0. Zeroing each of these out, we're going to end up with x equals 3 and 12. Or does it? We need to check these to make sure they actually make the original equation true. We might have some extraneous roots here. So let's plug 3 in first. I've got 3 minus 6 and the square root of 3 times 3. And I'm asking, are these two things equivalent? So on the left side, I've got negative 3. On the right side, this is the square root of 9. The square root of 9 is positive 3, which does not equal negative 3. That means that this answer of 3 over here is extraneous, and we have to eliminate that. Hopefully 12 works. Let's plug that one in now. So we've got 12 minus 6 equaling radical 3 times 12. Again, or does it? We need to find out. So this is going to be 6 on the left, radical 36 on the right. The square root of 36 is indeed 6. That works. So 12 is a good answer. For this problem, we're trying to solve this cubic root equation. Because the radical is already isolated on one side, we can go straight to raising both sides to the index of 3. So if I raise the left side to the third power, that just gives me 2x cubed minus 1. On the right side, we have x cubed. And since I've only got cubes and constants, I think I can solve this by just moving the cubes on one side and the 1 on the other side. So if I subtract x cubed from both sides, I have 1x cubed on the left. And then if I add 1 over to the right side, well, we've got 1. And then I just have to take the cube root of both sides. The cube root of 1 is just 1. So you might be thinking, well, if we have x cubed minus 1, isn't it also possible to factor this into, I think it would be what, x minus 1 and x squared plus x plus 1? But that other factor wouldn't give us any real solution. So we're just going to stick with 1 as our answer here. So now let's plug that back in and see if it works. So I have 2 times 1 cubed minus 1. That's just 2 times 1, which is 2, minus 1 is going to be 1. So we have the cube root of 1 on the left, just plain old 1 on the right. And the cube root of 1 is 1, so this works out. 1 is a good answer. For this problem, we're trying to solve this equation that has an x to the 2/3 in it. Let's start by isolating that x to the 2/3. So I can divide both sides by 2 to start off with here. That gives me 4 on the other side. And then to get rid of a fractional exponent, I'm going to raise both sides to the reciprocal power. So I'm going to raise both sides to the 3 over 2. That just gives me x on the left side and 4 to the 3 over 2 on the right side. And we do have to remember a plus or minus because when you raise something to the a 2 for the denominator here, that means you're really taking an even root. So we do need that plus or minus in there. So I'm going to rewrite this as the square root of 4 raised to the third power. And that's going to be 2 to the third, plus or minus 8 then. Those are going to be our two answers. Or maybe not. I mean, we've got to check them both since this is technically a radical equation. So I'm going to plug these back in with a radical already built in. So I have 2 times the cube root of, we'll do positive 8 first, so cube root of positive 8 to the second power is how I can rewrite all that. Cube root of 8 is going to be 2. 2 squared is 4, and 2 times 4 is 8. 8 equals 8, so that means that positive 8 is a good answer. Let me also plug in negative 8 to all this. So now I've got 2 times the cube root of negative 8 squared. The cube root of negative 8 is negative 2, which is a little bit different from over here. But if I square negative 2, it becomes positive 4 again, and 2 times 4 again gives us 8, which is what we have on the other side. So it turns out that both of these answers are acceptable. On this one, we are trying to solve this equation that has this x to the 3/4. Let's begin by trying to get this x to the 3/4 all by itself. So to do that, I can add 14 to the other side. That's 54. And then divide by 2. So we've got a 27 over there. And now to get rid of the 3/4 power, I'm going to use the reciprocal power, which is 4/3. So I'll raise both sides to the 4/3 power. That gives me x to the first on the left side and 27 to the 4/3 on the right. Now at this point I'm going to turn this into a radical so that it's a little bit easier to work with. This is really the cube root of 27 raised to the 4th power. The cube root of 27 is 3, and 3 to the 4th is 81. So this is my potential answer, but I need to plug this back in and make sure it actually works. So let me do 2 times 81 to the 3/4 minus 14 equals 40 and see if that actually comes out the same. So I can rewrite this exponent now as the 4th root of 81 to the 3rd power. The 4th root of 81 is going to be 3. 3 cubed is 27. And then 27 times 2 gives me a 54 for that first term. And then 54 minus 14 is 40. So that means that 81 is our answer. On this one we have x plus 6 to the 1/2 power equals x. Since I've already got this exponential piece isolated, I'm just going to raise both sides to the reciprocal power to get rid of that fractional exponent. So if 1/2 is the original, that means that 2 over 1 is the power I want to raise both sides to. So basically I'm going to square both sides. So that gives me x plus 6 on the left side and x squared on the right side. All right, well, this is just a quadratic. Let me zero this out and see if I can factor it. So if I rewrite this, I'll have x squared minus x minus 6 equals 0. And then I'm looking for things that multiply to negative 6 and add up to negative 1. 1 and 6 doesn't work. 2 and 3 works if I have positive 2 and negative 3. So x plus 2 and x minus 3 equals 0. And now setting each of these equal to 0 and solving, we have x equals negative 2 and positive 3. Let's plug both of these into the original and just make sure that this all works out. So I've got negative 2. I'll plug that one in first. So this is negative 2 plus 6, which is 4. And then the 1/2 power is really the square root. So we're really doing the square root of 4. The square root of 4 is 2, which does not equal the negative 2 that we plugged in over on the other side. Since these don't equal each other, that means that negative 2 is actually an extraneous solution, and we're going to eliminate that. Let's move on to x equals 3 now and hope for better things. So if we plug 3 in, we've got 3 plus 6 to the 1/2 equaling maybe 3, hopefully. This is going to be 9 in here, and we're taking the square root of that. The square root of 9 is 3. Since 3 equals 3, that means that this answer of 3 is the correct answer.